So this is question number 11 of JEE Advanced Paper 1 2026. As shown the figure, an inflating container fitted with isothermally conducting but immovable piston partition P1. Okay, so it's immovable, means volume here is constant, and beta it's conducting. Conducting means temperature both side will be same. Okay, and freely moving isothermally insulated P2. So this is Q is equal to 0, but movable. Thermal conductor cross sectional area A. Okay, so conductivity is K, and area is A, and thickness is X. Fine. So we cannot say temperature will be same now because it's a partially conducting, right? So it's okay now. Now P2 can move freely such that H2 is always at the atmospheric pressure. So here pressure is P2, P not always. So this is isochoric process, pressure constant. Okay, and Q is also 0 here. There is no heat exchange, but maybe this walls here we can exchange heat, right? So initial pressure, initial difference between the temperature of S1 H2 is T0. Okay, temperature is T1 and temperature is T2. T1 minus T0 is given by T0 delta T0. Fine. So time taken by difference to become T0 by 2 is this. Okay, fine. So what will happen, beta? Because we don't know which temperature is high, which temperature is lower, but whatever, if the heat flows from one side to another side, because this is isobaric, this will expand, and as it expands, the temperature will again change. Okay, so let's talk about something like this. Okay, fine. Let's draw the diagram now. We got the idea of the question that this is a conducting thing. So here this is T1 and this is T2, and this is a conducting piston which can freely move. There is no heat exchange here. So heat, whatever heat is exchanging, this is also conducting, insulating, right? Sorry. So first of all, heat, whatever heat will conduct from here to here, है beta? And we read the question divided into two sections. They are not saying equal section, right? है ना? So if they are not saying equal section, we cannot assume they have equal volume. And container 1, container 2 contain 1 mole. Okay, number of mole is 1 only. है ना? So first thing is that beta, because Q is 0, है ना? And but this piston will move, right? So because piston is moving, we cannot say W on the system is 0. So here we cannot say that energy of the system will be conserved. Means of course it will change. So work done by the surrounding, if I say here Q is 0, right? So we can say work done by atmosphere will be actually equal to delta U of the system. But we'll see whether it is used or not. First of all, we need to assume that heat is flowing from here to here, right? And as the heat flows here, the amount of heat flowing is dQ. And dQ we can get by the logic that we have, heat conduction. dQ by dt is given by Ka, which is K is K, right? A is A by X, T2 minus T1, which is delta T. Okay, so from here we know this is equation number 1. This is the amount of heat will flow that from T1 temperature to T2 temperature. Now this amount of heat is very, very small, beta. Because this amount of heat is very, very small, due to this heat, the piston will shift here, and let's say it will shift by some amount, so the pressure remain constant. So if pressure remains constant here, and we know we are not giving heat from this side, this is isothermal process, isoporic process, baric process, right? So this dQ will be equal to nothing but heat absorbed by a system is positive. So this will be nothing but equal to our isobaric process. We can see this is what kind of gas? Monoatomic gas. So Cv is 3 by 2R and Cp is 5 by 2R. So this will be written as isobaric process. So we'll say NCp delta T2, or we can say DT2. Fine. So N is 1 mole. This is 5 by 2, 1R DT2. Fine. This is equation number 2. And similarly, we can see one more thing, because it is losing heat. And beta, this is isochoric process. So here we can say minus dQ will be equal to NCV dt1, which is again 3 by 2, 1R dt1. Okay. So from here I can see this, that if I fill this value here, I want to see that change. And delta T is nothing but T1 minus T2, right? So I can say dt is equal to dt1 minus dt2. let's put it dt. So if I use this logic here, so from here I can say that from here dt2 is nothing but 2 by 5 q by r, and dt1 is nothing but beta minus 2 by 3 dq by r. Okay, from here if I put this value here in this formula, so dq by dt is nothing but ka by x. If I fill the value of dt, which is dt1, which is minus 2 by 3 dq by r, minus dt2, which is minus 2 by 5 q by r, dq by r, sorry. So first thing I will notice that dq got cancelled out, है ना? And we got dt by dt here, right? This delta t, no, sorry, this delta t. Wait a minute, wait. So let me remove this. A small mistake I made here. This is not dt, this is delta t. That is t1 minus t2. Fine. Okay, and because of that, till here it is okay. Fine, this is okay. है ना? So from here and here I can say that dt is equal to, if I use this formula here, dt1 minus dt2, so I'll get minus 2 by 3 dq by r, and then I will get minus 2 by 5 dq by r. So that will give me, if I take LCM 15, get 10 plus 6, I will get minus 16 dq by r, right? So minus 16 by 15 by r, but a dq value I can take from here. What is dq? We can say dq is nothing but ka by x, and we are calling this temperature as delta T. Okay, this is d of delta T. So we'll get minus k by a delta T into dt. This is d delta T. Okay, so from here d delta T upon delta T is coming out to be minus 16 by 15 r, and ka of course x, and we are getting dt. So from here what they want temperature to go from this to this. Okay, fine, we can integrate it. At t is equal to 0, delta t was delta t naught, and t is equal to d, it will become delta t naught by 2. So if I simplify this, I'll get ln2 with a minus sign, and here I'll get minus 16 by 15 ka by ra, rx into t. So from here t is coming out to be beta 15 ln2 by 16 ka by rx. Sorry, it will come out to be not k by rx, rx by k. So if I compare this, they are saying time taken for this become this is this is n xr by k. So if I compare this n xr by ka, the value of I am getting is 15 by 16 ln2, which I can calculate, right? So 15 by 16 ln2 is given by ln2 is actually given the question as 0.7. So if you round it off, you will get 0.66 nearly, or 0.67 type thing. Okay.